we introduced DiffFit, a new tool for visually guided differentiable fitting of molecule structures to a cryo-EM map. Fitting a molecule structure into a cryo-EM volume map is a common task in structural biology. The current widely adopted solution is the FitMap command in Chimera or Chimera X, the go-to tool in the domain. However, this process first needs to manually align the structure to the approximate final solution. Otherwise, the outcome fails into a local minimum, meaning the alignment is far from ideal. This FitMap command has a global search mode where multiple initial placements are seeded to bypass the manual alignment requirement. But for an adequate amount of seeds, for example 1000, the global search takes minutes to hours to finish for one structure, which is far from interactive. It will then be very tedious to composite multiple subunits into a target volume using this functionality. In computer graphics, Reddy et al. Recently published a differentiable compositing approach to solve the problem of compositing 2D texture patches into a target pattern image. Inspired by Reddy's solution, we developed a differentiable fitting algorithm followed by a human-in-a-loop workflow to solve a problem of compositing multiple molecule structures into a target volume. First, we need to extend Reddy's approach to work in 3D. Then, we need to come up with a new loss function to handle the different properties of the molecules and volumes from 2D images. Then, we developed several novel strategies to process the data and created a novel loss function. As a result, our algorithm performs robustly and tackles the local minima issue very well. We applied the algorithm to 3 use case scenarios. First, we want to be able to fit a single structure. One can see the fitting process of 3 structures in the animation here. We report a hit rate gain ranging from 35 times to 292 times and a computation time gain ranging from 131 times to 393 times. Second, we show compositing multiple structures. As a demo, 3 unique subunits of PDB-8SMK are fitted into its cryo-EM map. At the first round, all 3 subunits get in. The 2 copies of the bigger subunit and 1 copy of each smaller subunit are identified upon the user's inspection. The voxels corresponding to those subunits in the target map are zeroed out to prepare a subtracted map for the second round of fitting, in which stage the remaining copies of the 2 smaller subunits get identified. As there are no significant areas left in the target map, the compositing finishes and we get the complexest structure in 30 seconds of computation time and approximately 5 minutes of human-in-the-loop interaction time. Third, we demonstrate unknown protein identification. A recent work, DomainFit from Gao et al. Showed a demo dataset consisting of a volume map and 359 structures and posed the problem of identifying which structure should be placed in that map. In 10 minutes, DiffFit is able to identify the top 2 candidates and let the user inspect them visually, while it takes 12 hours for DomainFit to do so, which relies on Chimera X FitMap command. Apart from the quantitative metrics before, we report the following qualitative feedback from the user study. Our participants appreciated DiffFit's intuitive interface and workflow, which significantly lowers the barrier to entry for new users while still providing advanced features for experienced researchers. The visually guided fitting process, in particular, was highlighted as a powerful feature for refining fitting results based on expert decision. The participants reported that DiffFit has the potential to have a tangible impact on their research, enabling them to tackle complex fitting challenges that were previously out of reach. The new ability to rapidly and accurately fit structures into volumetric data opens up new avenues of investigation and has the potential to accelerate discoveries in structural biology.